All right, welcome everyone. We are verifying identities in this lesson. We've done this before in the last unit, Unit 5. We verified identities in our first trig unit. But we have learned a lot of information since we last were introduced to the idea of verifying identities. So today is all about using everything that we've learned up until now to do that same process, to prove that an initial statement on the screen here, tangent pi over 2 minus x is equal to cotangent x, using the knowledge that we have acquired. Now that's kind of ironic because one of the identities that we have learned is the one on the screen. But I want to prove this using something that we have since learned. Because the way we proved this a long time ago was we just drew a little picture, right? And we drew theta. Pi over 2 is 90 degrees, so pi over 2 minus theta. All right, and we just wrote some coordinates. We kind of waved our hands and said tangent of pi over 2 minus x is equal to cotangent of theta. That's a cofunction identity, by the way. All right. But what I want to do in this video is I want to prove the cotangent cofunction identity using the difference identity for tangent. So let me go ahead and erase this. After we prove this one, we're going to do 3 more examples of identities, just so you guys can see different techniques being used. And then we'll be out of here. So hopefully this is a pretty quick video. Enjoy. All right. So tangent pi over 2 minus x is equal to cotangent x. All right, so I'm going to use the difference identity for tangent. So tangent pi over 2 minus x, that's the tangent of the first angle, tangent, oh, and that should be a minus, tangent, 1 sine, tangent. All right, let's evaluate some of these. The tangent of pi over 2, that is the slope on the unit circle at pi over 2. That's right. Oh, wait. We have a conundrum. This is undefined. Tangent of pi over 2 is undefined, so this entire expression is undefined. We need to go back to the drawing board. Our tangent is undefined at pi over 2. Cotangent is undefined at 0 and pi. That's where the slope is 0, the reciprocal of that being undefined. Tangent is sine over cosine. Tangent of x is sine x over cosine x. I don't think this can be done using the identity for tangent, the difference identity for tangent. I think what we're going to need to do is turn it into sines and cosines. Sines and cosines are defined everywhere. The domain of sine and cosine is all real numbers. Let's write this as sine pi over 2 minus x over cosine pi over 2 minus x. All right. We're using the sum and difference formulas here. Yes, we could use the cofunction formulas, but that's not the point. As I've been making this point several times in class, the goal here isn't always just to do it. It's the journey, not the destination. We want to practice these identities. All right, so let's use the difference identity rather than the cofunction identity, because this problem is all about the difference identity. Sine pi over 2 minus x, that's sine cosine. Keep the minus, cosine sine, all over cosine, sine, cosine, sine, sine. Cool. All right, let's evaluate some of these things. Sine pi over 2. I could go ahead and draw a sine graph if I wanted to. I'm not gonna. Sine pi over 2 is the y-coordinate at pi over 2, which is 1. So that's going to be 1 times cosine x. Cosine pi over 2 is 0. That is the x coordinate at pi over 2. That's 0. 0 times sine x, that's just 0. Cosine pi over 2, that's 0. Plus sine pi over 2, that's 1. Sine x, we are done. Q, E, D. Quite easily done. Quid erat demonstratum. Cool. Right? Proving identities is so much more than just showing off that you can verify two things are true. It's about the journey. It's about being asked to utilize the difference identity and being able to. Having knowledge in your brain and being able to use it when you're asked to use it. All right? Which leads me into my next little tangent, which I've actually written out for you guys. Tangent is not a pun. No pun intended. But I got a little note here for you. And I'm just going to go ahead and read it. Note. Remember that, unlike an equation, we are not to assume that the left-hand side and the right-hand side are equal in an identity. In an equation, we are given that both sides are equal and we are tasked with finding the values of x that make it true. In an identity, we are not given that both sides are true. Well, technically you are. I'm not going to give you an identity that's not true. But for all intents and purposes, in an identity, we are not given that the initial statement is true. Our goal is to prove that it is true, that the left-hand side and the right-hand side are equivalent. By manipulating both sides, you are implying to the reader, to the person looking at your work, that the initial statement is true. You're begging the question. By manipulating both sides, you are saying that the initial statement is true, which hasn't yet been proven. That's your task. Please only manipulate one side, thus proving formally that the statement is true for all values of theta. So identities are different than equations. They're statements that need to be proven. Whereas an equation, you're told that that the equation is true, and you're trying to find the values that make it true. All right, so we are trying to use the skills that we have developed over the past month. So break out all the tools. Let's turn cosine A plus B into 1 minus tan A tan B minus secant A secant B. All right, we have lots of different tools that can help us do this. I see a 1 minus tan A tan B. That leads me to believe that there might be some tangent difference formula happening here, because that's in the numerator, just like, but I'm not sure. I think the best thing to do is to jump in and do something. I'm going to go ahead and use my sum formula on cosine A plus B. All right, hopefully eventually some tangent difference formula might appear. I don't actually know if it's gonna. Let's just see what happens. All right. Unlike last unit, we didn't have the sum formulas. Now we do. We can use them in proving identities. Okay. Cosine A plus B. That is cosine, cosine, sine, sine, sine. I mean it when I don't know where I'm going to go next. I do not know from memory how to do this problem, which I think is a good thing. Witness me struggle a little bit. Cosine A, cosine B minus sine A, sine B. All right, I want a secant A, secant B in the denominator. I think I just figured it out. All right, I want a secant A, secant B in the denominator. So what do? What I always do, I just introduce it. Times secant A, secant B. This is going to give me what I want in the denominator. But I can't just do that. This is algebra. I can't just weight down one side of the equation. I have to resolve what I've done. I have to multiply by 1 or add 0. Multiply by the multiplicative inverse or add the additive inverse, or the additive identity, the multiplicative identity. Sorry, 1 and 0. Getting crazy with my words over here. And I think this is going to do it because, let me throw some parentheses just to be clear. I'm going to distribute the secant A, secant B to these two terms. And I believe I'm going to get 1 minus tan A, tan B. I have my secant A, secant B in the denominator. And secant A, secant B times cosine A, cosine B. Well, secant A, secant B, that's just 1 over cosine A, cosine B. Secant A times cosine A, those are reciprocal functions. That's 1. Secant B times cosine B, those are reciprocal functions. That's just 1. 1 times 1 is 1. I have that 1 that I wanted in the beginning. And I believe the same thing is about to happen with the secant A, secant B, and sine A, sine B. Secant A, sine A, secant A is sine A over cosine A. Let me actually do that in 2 steps. All right, sine A, secant A, that's sine A times, let me just do a little, sine A times 1 over cosine A. That's sine A over cosine A. That is tangent A. Let me go ahead and erase that so someone reading my work isn't confused why there's just this equation hovering above my work. It's very important that your work at the end of the day is clear to the reader. And then sine B, secant B, that is tan B. And I have proven what I set out to prove. 1 minus tan A, tan B over secant A, secant B. I took what I was given, cosine A plus B, and I used the knowledge that I've acquired over the past month. In this case, the cosine difference formula. The cosine sum formula. And I was able to prove that this is true. All right, I did not use my initial thought of the tangent difference formula. All right, what you think of at the beginning may not actually be what you use in the process. All right, I got 2 more for you just so you can see identities being proven using this wealth of knowledge that we have. But once again, I don't know how I'm gonna do them. I really mean it when I say I did not look at any answer key before I did these. All right, we need to turn 1 plus cosine x over sine x into cotangent x over 2. Initial thoughts. I see the cotangent half angle formula. Oh, I think I just saw it. If you know all your identities in your brain, this is actually a pretty simple one. Huh. Let me think for a second. I need to turn 1 plus cosine x over sine x into cotangent x over 2. I think this is going to be pretty quick. Huh. I'm going to write some stuff on the side here. And let me make sure I don't draw underneath that blue line. So I draw where the crab is. You've been crabbed, Mrs. Contreras. All right. I know that tangent x over 2 is equal to the square root of 1 minus cosine x over 1 plus cosine x. But it's also equal to 2 other things. 1 minus cosine x over sine x and sine x over 1 plus cosine x. And I think that third one there is going to be the one I'm going to use here, because that is the reciprocal of what I've been given. 1 plus cosine x over sine x, that's equal to 1 over sine x over 1 plus cosine x. That's this. I think I'm home free. 1 over sine x over 1 plus cosine x, that is tangent x over 2. Let me slow down a little bit. Handwriting's starting to get sloppy when I get excited. And then I can use my reciprocal identity for tangent, and that's just equal to cotangent. Q, E, D, and you know what? I think I forgot a QED up here. Let me just... Let me hover over this page for a second so anyone who wants to pause here or take a moment to look through what I've done can do that. 1 plus cosine x over sine x. That looks like a tangent identity, the tangent half angle identity. And it is reciprocated. So I reciprocated it. I subbed in one of my identities. And if you forgot sine x over 1 plus cosine x is one of your identities, then you could have just reproven it. It's a little bit annoying, so maybe memorizing it is worth it. But knowing where it comes from is crucial. And then I reciprocated, boom, cotangent x over 2, QED, boom. That one wasn't that bad. I'm looking into my brain to all these identities that we've recently proven. And we've been using a ton. Now we have a cotangent half angle formula, 1 plus cosine x over sine x. We technically had it before. Okay, I got one last one for you. Right there. 1 minus cosine 2x secant squared x is equal to tan squared x. Okay. What kind of vibe am I getting? We got a double angle, cosine 2x. There are a bunch of different cosine identities, cosine double angle identities. We got cosine 2x, which is equal to cosine, cosine, sine, 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 where the angle is x plus x. So cosine, cosine, which is just cosine squared x. Sine, 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 which is sine squared x. But then we have all the Pythagorean equivalents, where we change cosine squared or sine squared into its counterpart. We got when you turn cosine squared into 1 minus sine squared, which is 1 minus 2 sine squared. And we have when we change sine squared into 1 minus cosine squared, where we have 2 cosine squared minus 1. All right, let me make sure I don't go below that for the crab. Okay. We want a tangent. And we have a secant. If I think back in this lesson, this was totally unintentional, but we did a lot of secant stuff. Sine times secant is tangent. Sine times secant is tangent, and I want tangent. I have a secant. I think what I want to do is turn the cosine 2x into a 1 minus 2 sine squared x. Because then I'm going to have the sine squared times secant squared, which is tangent squared. I'm going to do that. Let's see what happens. 1 minus cosine 2x secant squared x. I'm going to turn that 1 minus cosine 2x into parentheses 1 minus 2 sine squared x. Let me try to write this a little bit slower so my pen recognizes it. 1 minus 2 sine squared x secant squared x. Throw an equal sign there. 1 minus 1 is 0. 1 minus 2 sine x, that's going to be a positive 2 sine squared x. This negative is distributing to the 1 and the 2 sine squared x. So I'm going to have a 1 minus 1 plus, that's going to be 0, plus 2 sine squared x. Oh, no, I'm making a big mistake. I am messing up the order of operations. I got to deal with that secant squared x first. I got to deal with that secant squared x first. So we got secant squared 1 minus secant squared x minus 2 sine squared x secant squared x. All right, big mistake previously. I caught myself. Hopefully y'all were freaking out. Maybe I'll throw that as a question. At this point, if I did throw it as a question, you already know. Okay. Sorry about that, though. Okay. 2 sine squared secant squared, that is going to be 1 minus secant squared x minus 2 tangent squared x. We established before sine times secant is tangent. Sine squared times secant squared is tangent squared x. We need this to become a tangent squared, and we currently have 2 tangent squareds. I think it's going to be a grouping thing. Minus minus, we have a plus 2 tan squared x. Even when you've been doing this for a long time like me, you still got to stop and think sometimes. It might be right under your nose. I think secant squared and tangent squared can be related using a Pythagorean identity. Let me write that down on the side here. I don't want to go below that line. Tangent squared plus 1 is equal to tangent squared x plus 1 is equal to secant squared x. That's my Pythagorean identity. I'm going to replace secant squared with tangent squared. 1 minus tangent squared x plus 1 plus 2 tan squared x. I think we got it. 1 minus 1 is 0, and we have a negative tangent squared plus a 2 tangent squared, and negative 1 of something plus 2 of that something is equal to 1 of that something. Tangent squared x, q, e, d. That one was a lot more intense. Let me zoom out to like 150 so I can get the whole thing on the page. Boom. We used our Pythagorean, no. We used our cosine double angle formula. This kind of looks like a Pythagorean identity. It's not. Well, I guess we kind of used it here, Pythagorean identities. Pythagorean identities were used a lot in this problem. All right, but we used our double angle formula. We messed up. By we, I mean me. You did not mess up. I messed up in my order of operations. I was doing 1 minus all that stuff. I would have been in a loop. I wouldn't have been able to prove it. One small mistake can do that to you. But I backtracked. I checked my work, figured out that I forgot to distributed, and then I got my tangent squared from the sine times secant, and I used my Pythagorean identity on the secant. And then things just kind of fell into place from there. Tangent squared x. Beautiful. All right, there's your problem. There are your identities. I used several different tools, but we got lots of identities. We got the double angle formulas, which we use. We got the sum and difference formulas for sine, cosine, and tangent. We didn't use any sine or cosine half-angle formulas, but we did use a tangent half-angle formula, so that's kind of nice. We've kind of used all the identities. We even used the cofunction identities in this problem set. All right. I guess I'll leave you with this. Stroll up. Please don't forget my note here, where in these problems, the essence of these problems is to show that you understand all of these formulas. So only manipulate one side, turn it into the other side. In calculus, you will often be in that scenario where you're given something that is hard to work with, and you want to be able to turn it into something specific. So that is what we're practicing here, turning one thing into a given other thing. All right, there's no way to work around that. And do I have any words of wisdom? You know, this video is being filmed in March. It's March Madness. So my words of wisdom are, go Terps. See you next time, guys.